Hi everyone, I'm Mary with Mary Greeley News. Here we have an image of Old Faithful taken from the static cam. This is from yesterday, February 1st. Old Faithful went off 7 times yesterday, and currently it's about 17 degrees. But this is yesterday, so I imagine it was probably just as cold. I noticed later on in the afternoon that Old Faithful and some of the other geysers started putting out darkened steam, which means that the rock was heating up, bringing up that melted material. And you might notice some buffalo that came in. They're back over there. See them? There was another magnitude 2.4 earthquake today. And I'm surprised how quickly they reported it. I saw it on the earthquake monitor early this morning. Yeah, I'm really surprised that they reported it. It was 17.5 kilometers in depth near Silver Gate, Montana, which is close to Parker Peak and also close to this other area of a past eruption. They call it Sunlight Volcano. And then to the west, we have the area, okay, there's that 2.4, and then we have the area of the new thermal burn, which was burned up because the heat of the ground got so hot that it killed the trees in this one location in the Sour Creek Resurgent Dome. And this is the area that Bob Smith, who's worked for about, 55 years at the University of Utah, feels that when they have the next eruption, hopefully it's a small one, this is where it will occur. But if it occurs at the Sour Creek Resurgent Dome, more than likely, both resurgent domes would collapse at the same time. Someone on my last Yellowstone video asked me, what is a resurgent dome? On Wikipedia, it says here that it is a dome formed by swelling or rising of a caldera floor due to the movement or the flow of the magma chamber beneath it. Unlike a lava dome, a resurgent dome is not formed by the extrusion of highly viscous lava onto the surface, but rather by the uplift and deformation of the surface itself by magma movement underground. Resurgent domes are typically found near the center of very large open calderas such as Yellowstone caldera or Valdez caldera. And in turn, such calderas are often referred to as a resurgent type caldera to distinguish them from the more common, much smaller calderas found in shield volcanoes and stratovolcanoes. And if you want to read more, I'll give this page in the box below where it says more information. Now, the Sunlight Volcano is a field of volcanoes being about 33 to about 55 million years ago that extended southward as the eruptions occurred, going down towards the Washburn volcanic group, which is the youngest of these eruptions. I want to give you a quick image of how dirty this steam was that was coming up. Now this says here at 2:15 p.m. yesterday, and you can see it's a bright sunny day, so it's not from a shadow. Now this magnitude 2.4 occurred about 4 a.m. Central Daylight Time, 17 kilometers in depth, so that would be about 10 miles below sea level. That would be definitely in the upper magma chamber, but not near the roof of that upper magma chamber, which is 3.5 miles below the surface. The strain meter for the Norris Geyser Basin area still isn't working, but we have the spectrogram showing from yesterday. Let me bring this down a little bit. Like I said, they probably won't pull that borehole instruments to repair it, especially being in winter. Here's a diagram of a borehole strain meter installation. You can see it's a very deep well. In this case, it's 558 feet deep. And the strain meter is put at the bottom. Up above that would be the seismometer. And then at the top would be a cap of cement so it doesn't pick up any of the noise from outside. So when this component, the strain meter, breaks down, yeah, it's a big to-do to get out there and pull all the electronics. Now, from everything that I looked at today, it looks like uplift in the Norris Geyser Basin area is going on in the west. Channel 2, as you can see here, is west. Channel 1, kind of northwest. And then channel 3, southwest. This gives them an idea which way the ground is uplifting for tilt. What is tilt? Tilt is as if you took a round bowl, tipped it upside down, so you have the dome, and tilted the bowl in different directions, north, south, east, and west. Channel 0 should be up and down. That would be able to tell you if the ground also is rising or dropping. Inflation or deflation. The strain meter stopped working sometime last year. Here you can see we got June, July of last year, and you can see it was dropping up until then. So here we have the borehole tilt meter for the Norris, one of them. Borehole 950 for the Norris Geyser Basin area, and lots of dots means lots of shaking. X is north, they're measuring the tilt. Y is east, and they're also measuring the flow of the magma under the ground. Basically, this one's been pretty much straight up, but you can see the magma is flowing east, where it looks like the ground is rising slightly northwest. Each little dot would be an earthquake that either created uplift or was an indication that the ground was going down because of the earthquake. That's the last 7 days. Then the last 30 days, you can see how the ground was breathing, going up and down, shaking. But we got uplift here. It shows top is north, bottom is east, Y. Like I said, they're measuring the magma, which way it's flowing under the ground. Okay, and then this is what we got for the last 30 days. And it's slowly spreading out. You can tell by the distance here of the different phases from the last 30 days of the earthquakes. Now, another borehole they have at the Norris Geyser Basin area is borehole 205. Top is north, bottom is east, last week. Now, see how this is trending westward? But the flow is spreading out. It kind of did a backtrack of its flow. You can tell by the different coloring. The darker the color, the newer the earthquakes. So this is the last 7 days. Like I said, each dot would be an earthquake. And then going back the last 30 days. Top is north, bottom is east. And then, see that? Last 30 days they have for this monitor, westward. The uplift, if you looked at the ground, is rising in the west. And the flow of the magma under the ground is just basically spreading out, because we got X is north, Y is east. It's just right in the middle. Alright, so I'm going to show you the Madison River campground, that area, because that's going to be the next monitor that we're going to go to. The Madison River actually changed its course because of uplift. Changed the direction of its course because of uplift from the Yellowstone Volcano. Alright, so over here we got the Norris Geyser Basin area. And then over here is the Madison River area. This area here in orange that I have drawn out is an area of tree die-off. Not because of fires, but because of the gases and the heat coming up from the ground has killed off those trees. So here we have the Madison River tilt meter. This is from a borehole, 207. Top is north, bottom is east, last 7 days. And like I said, this is a very deep well under the ground, and each dot would be an earthquake within the last 7 days. The darker the color, the newer the event. Uplift here, it looks like, if you're looking at the ground, is slightly westward, but northwest. the magma is flowing under the ground going east. And then, like I said, up and down where you can see the spikes is when the ground was taking a breath. More dots means more shaking. And this would be for the last 30 days. And look at this, it's off the chart. They're going to have to reset it, and it's set for 2 microradians. I guess they weren't expecting the uplift to suddenly trend more so. Here we have the strain meter for the Madison River area, February 1st. And this one is still working. We have a spike in green, which is channel 2, and a spike in red, which is channel 1. Channel 3 was down, but then all of a sudden it went up also. Channel 0, which would be up or down, is holding steady. Very slight motion, maybe like a slow moving wave. So the ground is tipping, but it's not uplifting here at the Madison River area. So we got channel 1 and channel 2, and then also channel 3, which would show uplift going towards the west. Now, if we go to this other chart, which goes back to the 25th of January, you can see how we got blue dropping, but red and green rising, which again would be channel 1 and channel 2. Again, in this direction, and only recently has channel 3 been going up. And then I'll go back to the tilt meter for the Madison River area, Borehole 207. Top is north, bottom is east. And like I said, it's going off the chart, and they need to change that because it's only set for 2 microradians. Alright, the strain meter for Yellowstone Lake. Remember, that's on the northern shore, up there by the outlet for the Yellowstone River. And I talked about how we got uplift, and I talked about how we got that crack, the spreading, the widening of the lake itself. And here you can see we got uplift, which is channel 0. And then we got mostly the blue line slowly rising, and then the green one kind of fluctuating, and then the red one also slowly rising. I talked about how the lake is tipping because of the uplift on the west, and then we got the flooding that's going out on the eastern side of the lake, and how we got new beaches over there, etc. On the western side of the one thumb. And then here we have the borehole 208 for Yellowstone Lake. Top is north, bottom is east. Last 7 days. And here we got uplift. If you look at the ground looks like it's rising in the north, but we know the lake is tipping. Magma is flowing. Remember, top is north, bottom is east. That's the direction the magma is flowing under the ground, eastward. And then the last 30 days, there we go. And yeah, again, we got a dot way outside the disk. Alright, here we have Grant. Now that monitor is on the southwest side of Yellowstone Lake. Top measures north, bottom measures east. You can see how it was taking some breath last 7 days. Right, 7 days, yep. Okay. You can see here the ground. If you looked at the ground, it was rising in the west, which means in the east you got the flooding. Magma is flowing east. Remember, I talked about this Y here that constantly changes. So they're not just measuring the ground tilt, they're also measuring which direction the magma is flowing under the ground. And Yellowstone is one of just 5 volcanoes around the world where they're monitoring what direction the magma is flowing. I don't know what the other ones are. Alright, last 30 days for Grant. Again, top is north, Y is east. Yeah, look at that. And look at that for the last 30 days. That's a lot of earthquakes in the last 30 days. We're here on this map, they're only listing 17 earthquakes, and 2 of those were caused by quarry blasts. That's what the little triangle, oops, let me bring this back out. That's what the little triangles are, is quarry blasts. Let me bring this up for you. I got one there, which was a 1.3 and a 1.0. Oops. Okay, that was minus 2.0 kilometers in depth, which means it was above sea level. All earthquakes are measured from sea level. And this other 1.3 minus 2.0 kilometers in depth. Whereas this disk here shows the last 7 days of earthquakes. Let's see, should we count them? These are earthquakes for the last 7 days, and there is definitely more than 17 earthquakes. 2, 4, 6, 7, 8, 9, 10, and then you got a blob. Yeah, go ahead and enlarge it, and you will see for yourself that there's more than 17 earthquakes. All right, the last 30 days. There you go. So before I show you the spectrograms that I pulled, we got a current live view of the camera. We actually got out there and fixed it for a change. It keeps stopping and going. And there's a few people out there. Bright, sunny, and very cold day. So here we have that 2.4 earthquake. Now this one here comes from the Borehole 208, which is Yellowstone Lake. And we'll look at the signature. It's got a small P wave on it. We know it occurred northeast. And here it is for West Thumb. And this one here is for the Norris Geyser Basin area. And we'll look at the spectrogram. Oh, doesn't want to work. There we go. Then there was another earthquake. Let me show you this one. This one's not being reported. Right there. Yeah, see the line of melt. Yeah, thicker down there than up there. And I've talked about that. Let's see, what time is that at? Yeah, there we go. Alright, and this is what it's currently showing. This here is Yellowstone Lake. I'm going to pull this and see what this signature looks like. Let me pull it over for you. Okay, those are all earthquakes. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. All in a row. Did I count that one? 10, 11. Yeah, there's a lot there. And those are regular earthquakes. Not tectonic earthquakes. Like I said, they're all one and the same. Alright, we'll bring this over. Yeah, caused by uplift. The ground getting very brittle there as the ground rises. Inside the park, because of how brittle the ground is, it would not be a large earthquake prior to an eruption. Not like outside the caldera at Hedgen Lake, where they did have a large earthquake that did not go along with any volcanic eruption, because the ground's not as brittle over there. The National Park Service has an image of Yellowstone Lake. Hedgen Lake, where they had their earthquakes, is up over here. This is the area of the caldera where the ground is very brittle. And then I noticed earlier, let me bring this up, there was what they call blobs of magma that came into the system. Look at that. Now this here is Yellowstone Lake, and this here is West Thumb, and this is the Norris Geyser Basin. I just picked whatever. Let me see if I maybe can get the same time frame. Let's see. There you go. So Little Thumb, West Thumb, that's that caldera. We've got some more stuff going on here, and it showed up there. And let's see, we'll go over here, Norris Geyser Basin area. And you can see all the earthquakes up here, and yeah, we got another series. Where's this at? Right there. Let me pull it across for you. Boom, boom, boom. Let's see, 652. That would be this right here. Let's extract that. And we'll make it larger. Now that's in red, so they know that it happened there at the park. And it's in red so that the geologists know to come and review it. Yeah. Yeah, this occurred later. And I'll show you where that's at. That's right down here. I'll take a look at this. And then I want to show you, I'm going to go forward. I want to show you that 2.7. Alright, so it was closer to Yellowstone Lake's monitor than at West Thumb or Norris Junction. We'll pull Yellowstone Lake's first. There you go. Yeah, that's the 2.7. Or excuse me, the 2.4. And we'll pull the other one from West Thumb. And then we'll pull it from Norris Junction area. 2.4. And this is currently what it's showing. Yellowstone Lake, West Thumb, and Norris Geyser. Well, I'll take a look at this one. Alright, I'll pull a little bit bigger. You guys probably noticed it and were wondering what that was. Yep, another earthquake. Yeah, it's got harmonic tremors to it, which means magma's on the move. Another time frame. We got 1504 Universal Time, harmonic tremors. There's another quake over here. I want to pull that one. It shows up here at Yellowstone Lake, and this is West Thumb. Yellowstone Lake's larger. Yep, a regular earthquake. And West Thumb. Yeah. Let me take a look at this one. This is at what time? 23:37. This is yesterday. This one, let me take a look. It could be tectonic. Nope. Nope. And harmonic tremors. Look at that. And we'll go back a little bit. Lots of stuff. Oh, we got a nice blob there. That's at Yellowstone Lake. Like I said, Yellowstone Lake, they got that crack down there. Look at that. Let's start with this one right here. See what was going on at the beginning. Yeah, blobs of magma. Yeah, you can see how it was kind of pulsating. I'll pull this over for you so you can see how it continued on. For each line is an hour. Yeah, another one there. Just pull these as examples. Another earthquake with harmonic tremors. Anyways, that's all I have for you today. I did notice, and I've mentioned this before too, this one area here which has been heating up, which is getting extremely large. But if you have any thoughts or comments or questions, put it down below. Please stay safe, and I will talk to you later. God bless you. Bye.